to trip on everything.
Understandable.
I don't want to trip.
That's funny,
It's a classic track.
Oh, that's
Yeah, look at the setup.
yeah.
I always think that's a weed test. I know.
Everybody does.
I always think
Everybody.
Like, getting big.
Yeah.
Like, dude, this guy's hitting it a lot.
Shit's so actually high.
This guy, out of his mind. Okay. What do you want me to do? You want me to sit in the chair or wait? Sit in the chair? I'm sitting in the chair. Oh, you want me to move over? I don't know. Yeah. I have a slide. I have a slide. Everything is a line. Huh? 5 minutes. I'm gonna go for a walk. I'm stressed. No? Stay seated. Oh, I'm not going anywhere. Hey! Apparently we're live. Good to see you. Yeah. George, good to see you. Good to see you. Yeah. I have your thing in my car. I cannot get it for you for another 30 minutes.
Yeah. I didn't know this was happening until like George had sent something and like I was like, why did Nick say he might be here at 6? Or he might be around 6?
Yeah. No, that was vague. That was like, no, I will 100% be there on Monday. Do they have a mic? Are we good there? Yeah, you got it. Yeah. Deliberate. This is me. This is the anti-vibe coding. This is an anti-vibe code. This is you'll see on the second slide. How's my hair, Emilio?
You look like a professor.
I need glasses. Let me try these out. I don't think these are professor glasses. I don't think so. I don't think I can pull these off. I need my gold glasses.
You mean to back up from this? Where do you want me to go? I can go wherever. All right. Oh, no, you're good. I mean, you never have to apologize when you're bringing food like that in through.
Mic test?
All right, so Tom, should I talking to the big speaker too, or just this guy? All right. Can I yell at everybody to shut up?
Hey guys, all right. Real quick,
I'm going to describe this to everybody, I guess, and we'll see how it goes. All right, so this is a new event that we're going to do periodically. We're calling it Champions, and here's the high level of what we're going to do. Is that going on? And yeah, I can hear myself in my pocket. We'll see how it goes. All right, sorry. So here's the high level of what we're going to do. So we're going to bring back a Gauntlet alum every time we do it, and it's going to be a little bit different of a format than the streams that we've normally done in the past. So this week, Nick I overheard him describing this as the anti-vibe coding talk. So he's going to be talking a lot about how to build stuff in nasty enterprise environments and not drive yourself insane when you're trying to use AI in those environments. But here's how the format's going to work. So we're going to have a mic for Nick, and he's going to be walking through some of the stuff. And then we're also going to have a mic that we're going to pass around in the audience and have it be a two-way discussion the entire time. So this is not going to be, as much as we love Nick, it's not going to be Nick lecturing at us for an hour. It's just going to be a discussion about what everybody has discovered, especially Nick. He'll talk about why he's in the depths of woe of AI land. But yeah, so that's the basic theme. The theme of tonight's discussion is, okay, cool, it's fun to vibe code cute stuff. Now, when we go into real enterprise environments, when there's security, when there's a lot of nasty code bases, how do we best use AI in those worlds, which is 99.9% of actual engineering work that happens on the planet. So with that, I'm going to turn the time over to Nick to kick us off. We are streaming this live on X, as we tend to do. So know that your either intelligent or insanely idiotic questions will be broadcast for all, and we'll go from there. So I guess we'll call it deliberate AI engineering, given the title. So
Given
awesome.
the title slide, yes.
Tom, should I pass this mic to the audience?
Yeah, real quick, if you take the mic, please don't talk to the mic or laugh and stuff, because it's literally live. We're live streaming on that mic.
Emilio, do we need a mic check or are we good?
We trust Natalie.
Oh, yes. No, I'm ready. Yeah, let's do it. So, yeah, please. No, I love it. Yes. The audience is here. So, yeah, kind of like Austin said, you guys have a microphone. I have a bunch of slides. Feel free to interject. I'll solicit questions, throughout. But I'm very comfortable speaking, so please just speak and I will pay attention. So yeah, deliberate AI engineering. I put together this slide deck as a sort of anti-vibe coding talk, kind of just how to responsibly use AI tools. So how I learned to vibe code for a real engineering environment without driving myself or my coworkers insane. Also, how to not get fired 3 months after you install Claude Code. So that's the theme for the talk. So the talk is, so an examination of how to effectively use AI coding tools to produce production-ready code. All right, who am I? Nick, I did Gauntlet AI cohort 2. Woo! Yes, no, we're here. The second cohort. I've worked as a software engineer prior to that for 5 years, 4 years as a product engineer, 1 year as a solutions engineer, and then prior to that, I worked in marketing, actually. So, two-part talk. So the first is deliberate AI-driven development. So just sort of a practical workflow to make production-ready code and not get fired. And then the second is sort of novel, fun things that are on the horizon that I've kind of seen that are I think worth paying attention to. So yeah, let's do it. What inspired this talk? So I think it was like the first, or maybe the second, I think it was the second week of Gauntlet. So just for context, the structure of Gauntlet, it's 10 weeks. Every week you do a different project, and you have to use AI to code up some application. The first week was spent on me just trying to take my hands out of Vim and stop manually writing code and just learn how to at least try and use the AI tools, all of them, Claude Code, Cursor, what have you, the CLI tools to write all the code for me. But then the second week, at the end of the second week, I was looking at the code that I'd written with the AI tools, and I was sitting there thinking, and I was like, this is fine for like a 1 week project, right? Like it does all the things it says it does. It's not super buggy, but looking at the code, I was less than enthused with sort of what I had produced, and was sort of very confident that the methods I had used that second week would be entirely unacceptable in any actual coding environment, where you have to work with other people and your code has to work and be maintainable long term. And so, yeah, that's kind of the first half of the talk, is how I progressed from that point to not doing that. So yeah, a couple of things. What's wrong with vibe coding? We all love vibe coding. The first thing that's wrong with vibe coding is that it's fun. Vibe coding is incredibly fun. You speak and the AI brings your vision into reality. It's very fun to do. It's very addictive. It's cool. The second part of what's wrong with vibe coding is that it works. It actually does work. You don't actually have to have a very serious process to build an application that actually does what you intended it to do. You can get pretty far just telling Claude Code to keep going and to fix it. As long as you have some idea of what you want, it will actually work and you can get an application up and running. The problem is that it's dangerous. So if you are working in an actual code base and you start doing this, you can very quickly just start to blow things up. So you can trivially create huge bloated PRs. I think when I was, right, so like during Gauntlet, I had like a very basic process of like, I'm gonna make a branch, I'm gonna do all my coding for some feature onto that branch, then I'm gonna merge it back into master. And I would be merging feature branches that were like 5,000, 10,000, 15,000 lines, and I'm like not reading it. And like anything could be going on in there. You get these big bloated PRs that have like a bunch of code. You don't know what's in it. You have a bunch of code that you either don't understand or doesn't need to be there, just like random cruft. You get all your MD files. Claude loves his MD files. All the agents love their MD files. So you just get a bunch of stuff in there that you don't want in there. And then, especially if you have a lot of code and you don't really understand it, and you're sort of working within an ecosystem where there's already a lot of functioning code, and that code all needs to continue to function. If you start trying to merge in or successfully merge in a bunch of code you don't understand, you could fuck everything up really quickly. And your coworkers will not like it. And your boss is going to get really mad. Your CTO is going to get really, really unhappy that you are attempting to pollute his code base. And it's not yours, it's his company. He's running it. It's his code base, it's his repo. And you are trying to fill it up with bullshit. And he's not going to like that. And your coworkers who are going to be tasked with reviewing your PRs and working with all of your code, they're going to get enraged at all of the sort of the extra work you're making for them to try and understand what in God's name you've done and are attempting to do with their code base. So if you just straight up vibe code in an actual, I don't know, enterprise environment where the code has to be deployed and has to work, people are going to get really unhappy, and they're going to get really unhappy really fast. So yeah, AI-driven development. How are we going to build production-ready code with AI? What's the process? So it's a pretty simple process for me. There's 3 steps. I think most people here and most people who use AI and have tried to use it have something along these lines. So the first step is just researching and planning, and then you do your actual coding, and then maybe not most people, but one would hope you do code review. So I'm just going to walk through each of these, what I do. I am sort of like a vanilla CLI user. I don't use like a lot of plugins or like extra stuff. I'm generally just working with either Claude or the new Codex CLI tool. Overall, it's a pretty simple process. There's some stuff that I've sort of developed that works for me, but it's pretty specific to me. So I'm not really going to get into like those kinds of details. I'm going to try and keep it high level and just focus on kind of the big things that I think make a difference for my process, and then hopefully people can take something away from it. Yeah, so research and planning, this is by far the most important phase. The actual coding part of it is, and maybe I'm feeling the AGI too much, the actual coding part of it feels significantly less important than the upfront work before you have the AI write any code at all. So yeah, okay, so what happens when you skip doing planning? You get a bunch of problems. Let me see, yeah, here it is. Like I said, vibe coding works. You can get something that technically works. So if you just say, hey, I want to do this thing, go do it, it'll do it. And that's actually a problem because you won't know that you have other problems. Like theoretically, you could just take the slop that you have produced and go to your coworkers, try and get it deployed. But it's completely disconnected from your code base. So the AI agents, if you don't do any upfront planning within an existing code base, will duplicate a bunch of functionality. They will not use shared utilities. They will not do things in the style and convention that the rest of the code base is done in. And of course, you create massive PRs nobody can review. But the main thing is just your code will not be aligned with any existing code base. And the code base, most of the time, as an engineer, this is not, maybe 50% of the time, 50% of the time, the code base is the way it is for a reason. And things are shared utilities and the styling are all done in a certain way, and somebody thought about it and they put at least some thought into it. And whoever that person is, even if they don't still work at the company, they would like you to continue doing things that way. It makes it easier for everybody. It makes it easier for future AI agents to work with the code base, to sort of do things the way that everything else does it and use all of the existing parts of the code base the way that they were intended to be used. And so if you don't do a lot of planning up front, you're going to get a big sloppy PR. You're going to get fired 3 months later. So yeah, in this planning phase, it feels like this is when you're sort of doing all of the actual engineering work, right? So you're doing all of your system design up front, which is sort of the normal like engineering process. You're just using the AI agents to help you do it, right? You're evaluating different options and trade-offs. You are pointing the agent in productive directions, right? So when you're planning out whatever you're going to be doing, a lot of times the AI agents will come up with ideas that are maybe subpar, and you want to kind of cut them off right out of the get-go and say, we're not going to do that plan. We're going to do something that actually works. And then the most important part of the whole planning phase is to aggregate all the relevant context within the code base to sort of prepare you to do the actual coding part of the job. And so this will be relevant files, stylistic things, shared utilities, all the parts of the code base that you're going to need to work with. You want to aggregate that all up front. And it makes the whole coding part work a lot better when, like if you ask the agents to just go off and code stuff, they'll do some research into the code base, but a lot of times it won't be enough and they'll miss things. And so you want to sit there with the agent up front and just sort of repeatedly distill down what it needs to do. And in terms of actual process, where you want to end up, or at least where I want to end up when I do it, is before I start coding, I want to have one big document prepared that's everything I need to do the actual coding, right? So every relevant file, every stylistic thing, all of these things we talked about, I want it all in one place before I get started so that I don't have to, when you actually get to coding, you can just let the agent code and you don't have to rely on it to sort of figure things out as it goes, because you're going to have enough problems as is just trying to get it to code correctly, and you don't want to have it to be doing any research you could have done up front. Yeah, okay. Like we said, yeah, I don't know. Before I keep going, I'm going to go into the details of how I actually do the documents. Questions, comments? Is anybody offended by anything I've said so far? All right, we're going to keep going. So I do this sort of 3-document approach. So honestly, it depends on what I'm doing. You can do a lot of things when you're coding.
I had a question for you.
Yeah, okay. Yeah, hit me with it.
Actually, so we do vibe coding a lot. Well, good vibes.
Who's we?
at my
us.
company.
Oh, at your
yeah.
okay.
So Function Health is AI forward.
Yeah.
But there's a balance to be met between not having enormous bloated PRs
Yes.
and also delivering with velocity and proofreading
Oh, I
and
hate
testing.
it. I hate it. They're always telling me to go faster.
Yeah. So
Yeah.
what do you think about that? How do you
I
find
think
that balance?
I think that there's sort of an eternal equilibrium of the PMs making promises to leadership and leadership putting pressure on the PMs, and the pressure flows down to the engineers saying, do it faster, do it faster. And especially now when we have AI, why isn't it going faster? We need to be going 10 times, 20 times faster. And I don't think anything in AI really affects that organizational equilibrium. I think that's just always going to be there, and the engineers are always going to push back and say, no, we need more time, we need to do things correctly. And the other side of the equation is always going to say, no, we need to get this out faster. And I don't think either side of it is wrong. I think the engineers are right that like the more time you spend up front doing things correctly, the better your code base is, and you can continue to maintain velocity moving forward. And I also think that leadership is correct that like you really do need to go really fast in a lot of competitive markets where it doesn't matter how good your code base is. If we lose, we're all fucked. You all get fired. We all get fired. The investors all lose their money. And while there may be like a moment now where like, if you're working at an organization that isn't super AI forward, where like you have like a little bit of respite, where like if you're using the tools and maybe they don't know you're doing it or not as effectively, or they don't know you're doing it as effectively as you are, then you can kind of like buy yourself some extra time to go do other things and keep all your code nice and clean and organized. But I don't think that part of the equation has changed really at all. I think you're in a competitive market. Everybody's adopting these tools. Everybody's going faster. And I think that pressure is always going to be there. And the organizational requirements to sort of negotiate where you land on that spectrum, I think is still there and still needs to be navigated pretty much the same way that it has been. Basically via, I don't know, a lot of passive aggression between different parts of the organization. Yeah, so I don't know. I don't have a lot of advice there. I don't think there's a big change. I think some things are eternal. So back to documents. So these are everybody's favorite, the MD files. Everybody loves the MD files. Cursor is writing MD files. Codex is writing MD files. Claude loves his MD files. And one thing that I saw here at Gauntlet was everybody would say up front, they would plan what you're doing up front. Write a PRD. You have to write a PRD. And it has been lost upon me what PRD actually stands for. Does anyone know? Project Requirements Document. So if you ask ChatGPT what is in a project requirements document, it spits out a bunch of stuff. And when you're just coding, it has a lot of stuff in a PRD that you don't need. Like a PRD is almost like an organizational sales document to like justify whether or not the organization should invest in a new project. Like it's a very specific project management document. And when you're just doing, writing your feature or whatever, you don't need a lot of the things that are in a PRD. And if you ask an LLM to write a PRD, it's going to try and write an actual PRD, and you're going to be wrestling with it to try and get it to not do a bunch of stuff you don't care about. And it's going to make, like a lot of times PRDs, I think, just don't end up very effective, and writing them can be quite difficult because you are in conflict with the LLM. And so what I did, and I did this pretty quickly here at Gauntlet, and I think it worked really well, was to split up the whole document process. So remember, we want to end up with one like master document to go into the coding. But I found myself trying to write these PRDs, like, because you have the context windows when you use the agents, just like burning through the context windows, trying to get the LLM to not do a bunch of stuff I didn't care about. And so what I first did was just, there's this thing called a feature brief, and you can also call it an epic brief. They're the same type of document. An epic brief is for multiple features, but basically it's just a description of what you want to do. Usually in terms of like user stories, I want the user to be able to click on this part of the website and this button, and I want it to do this and that. And if you pull that part of what would be in your PRD out into a separate document, you get two things. One, the LLM is just super focused on, all right, we're doing what a feature brief is, which is just what are we trying to build here? What does the user want to do? And then two, you can iterate on it a lot without the LLM trying to do a bunch of stuff you don't want it to do. So if you pull out this feature brief document right out of the get-go, it just makes the whole process a lot cleaner. So you write this feature brief MD file or an epic brief if you're making a bunch of features at once. You iterate on it with the agent, you get one file, and then you clear your conversation, because all this is about managing context. You clear the conversation, you have the LM read this feature brief, say, hey, this is what we're building. Now let's talk about how we want to build it. And back to the PRD, people are always talking about like make an implementation plan. You want to have some sort of specific plan on how you want to write the code. You don't want to do that yet. The implementation plan, in my mind, it's very easy to put a bunch of this sort of system architecture work into your implementation plan. And again, you start to wrestle with the LLM. And so again, you sort of pull out this architecture part of the conversation, which is the high level, how are we going to build this? And this is where you do all of your sort of research on like, what's in the existing code base? How do we want to architect our solution to deliver on these user stories that we want to implement? And again, you can sort of iterate over and over and over and do as much research on the code base as you want and slowly aggregate all the information you need into this second document without having to wrestle with the LM about it wanting to do like specific implementation details. And here's how I would actually go and code up everything. So you do that second document, and then you do the same thing again. You clear the conversation, you load both of your sort of finalized feature brief, your system architecture document, and then you ask the LM, now I want to write a specific implementation plan on how we want to do the actual coding of what files we want to touch. And when you're doing these implementation plans, again, you kind of don't want to just like YOLO it and just say, hey, write up an implementation plan, and then we're just going to jump into coding. You want to iterate with the LLM on what order are we implementing things in? Are we doing this at the right level of sort of granularity? And then specifically, this is one thing, when you do implementation plans, when you like, what I do is you do these phased implementation plans, and it's like, we're gonna do this first, this. For each one, you wanna have them validatable by the user, i.e. you. You wanna be able to check after each step in the implementation, did this actually work? Because it becomes, if you try and implement everything all at once, it becomes very, very difficult to debug the mess you've made. And so you want to do one thing at a time, debug it at each step of the way, and you want the LM to write your plan in a way where you can do that. And so step one, we want to do migrations on the database. And then okay, let's go make sure we can actually insert records with the full schema, and does it actually work as step one? And then you do that for each step through, and then you can sort of layer like an effective foundation, and you can just like build on it, rather than if you just try and do the whole thing at once, you get a big pile of slop, and then you're sort of desperately trying to untangle the mess you've made. So this has made a huge difference for me in producing code that I understand and works correctly, does what I want it to do, and isn't sort of like desperately dragged across the line of like, the buttons work, I don't know what's going on, it's good enough. This sort of process of pulling out your documents lets you avoid that situation. Okay, so now coding, right? So you have this final implementation plan. It's sort of like, again, you clear the conversation, load in this implementation plan, say do the next one. I don't like let the coding agents just go off on their own. Like when you use Claude Code or any of the CLI tools, like they print out a log of what they're doing. And then same with Cursor, like you can see all the file changes. I just watch all the file changes as they go by. I'm not doing anything else. Occasionally I will play a game of bullet chess on my phone, and then I'll scroll back up. But in general, I'm watching what the AI does, because half the time I am pressing escape and saying, no, we're not doing that. Why are you doing that? What are you doing? I don't like what you're doing. How did we end up here? And getting the AI agent back on track. Because if you just let it do its own thing, it's going to do a bunch of stuff. And they're so intent on like delivering to you what you asked for that they will sort of route around their own mistakes and like add more cruft and bullshit to the code to get it to work. And if you just stop it before it does that, you can steer things. So that's the first one. Yeah, so this kind of goes into the same idea. So Scan Master Claude, anybody who's used Claude or Claude Code, and I think to be fair, even like GPT-5, Codex and whatever, they lie. The agents lie. They lie all the time, and they write complete horseshit code that, like, they will, like, you'll watch Claude, right? Like, connect your front end to the back end and be like, he'll write a comment being like, this isn't working, and then he'll just mock out the API. And if you're not paying attention, you'll be sitting there looking at a UI that looks the way it's supposed to look. You'll click on the buttons, and it will appear that they are doing what they're supposed to be doing, and it's completely bogus because Claude lied to you because he didn't want to disappoint you. And so, yeah, he does. He has you right, and he wants to deliver to you what you asked for. So Claude and the agents just lie constantly, and if you're not watching, you end up, you like continue to build on this lie, and you have to like unwind everything and try and figure out what the fuck was going on. You have to go read like the PR and be like, why isn't any of this working? Why doesn't anything do what I wanted it to do, even though it looks like it does, which is the most infuriating shit on earth. And so this goes back to that keeping an eye on the agent. Like, I don't let it run in the background because it will actively lie to you. Yeah, so mocking out APIs. If you're trying to do tests are the worst because it will write fake tests that always pass. And then my favorite is that it will say things are done when they're very much not done. Yeah, just like you get the confetti emoji. Yeah, go ahead.
So somewhat related to that,
Yeah.
One of the most powerful things about the LLMs is that they know a hell of a lot more than I do.
Can you speak up? I'm sorry.
Sure. So one of the most powerful things about the LLMs is that they know a hell of a lot more than I do.
Yeah.
About things that I'm unfamiliar with.
Okay.
Right. One of the failure modes that I've run into quite a bit is when I don't know that what it's doing is trying to route around some fundamental limitation of the technology that we're implementing.
Right.
In order to try and get shit to pass, or in order to try and, whatever it is. Do you have, besides read the documentation, because let's be honest, we're not going to do that.
Okay.
Do you have an actual strategy for how to approach that and how to figure out, not necessarily when it's straight up lying to you, but when it's trying to find a way to accomplish what you've told it to do, which you shouldn't have told it to do because it's not technically feasible?
Yeah. Okay. I think kind of two things. One is like hard-earned judgment. Like as you work within a specific code base or use a certain set of tools more and more, you just start to understand how they're designed to be used. If you're going into something like you're just vibe coding something that, or working with some set of tools you've never worked with, I don't think there's like an immediate way to not have that happen. I will say though, that if you ask the agents up front, like, in my plan, in my architecture diagram, am I using these tools the way they're designed to be used? You will actually get good results. It will actually tell you, no, you're doing something really stupid here. And oftentimes when it does that, you should look into it and try and listen and figure it out. Because holy shit, we had, here in Gauntlet, we had game week. And I'm like a masochist. I tried to do something fun and very difficult. I tried to make a game I didn't want to use WebSockets because I'm a hipster and I'm better than WebSockets, and I'm cooler than WebSockets, and I'm better than the people around me. And so I wanted to use UDP to make like a real-time game, which is web technology for doing like real-time streaming that doesn't use HTTP or WebSockets. And I came up with this brilliant plan, and I found this framework that did like the video game framework written in Rust that did UDP, and it used WASM and all this stuff, and I came up with this great plan. And amusingly, Claude was telling me the entire time, this is a lot that you're trying to do here. And I ran into this situation. So we do these week-long projects. I burned 4 of 7 days trying to do something that was impossible. I was trying to use UDP locally. You can't do that. And then I was trying to use this framework. I gave up on UDP and I was just like, fuck it, I'll do WebSockets. But I kept trying to use this framework, which was built around UDP, and I was trying to deploy to production using WebSockets, which was also impossible. And I figured it out after 4 days. Afterwards, I just asked Claude, hey, this framework, what's the proper way to set up a dev environment? And it's oh, you use WebSockets locally and you use UDP in production. And if I had just asked up front, hey, this tool I've never used before, how's it supposed to be used? Claude just spat out the answer instantly. And it was very much like a revelatory moment of the LLMs, like you said, know a shitload of stuff, way more than you or I or pretty much anybody at this point, about a lot of different things. But if you don't ask, they won't tell you. So if you're using tools that you're unfamiliar with, or you're working in a code base that you're unfamiliar with, you have to spend time up front, literally being how am I supposed to use this? How is this intended to work? And then I think to your question of how do I know when I'm watching the LLM spit out the logs? How do I know if there's some fundamental problem? I think you start to get a good eye for when the agents have gotten off track, and then interrupting, stopping, and saying all right, what's going on here? And just starting to query what's going on. And depending on your judgment and your satisfaction with the answers, trying to move from more detailed reasons about why things would be wrong to more and more general reasons. And being willing to ask, is this whole idea of what I'm doing just completely bogus? Is actually very productive. So that's what I would recommend that you do. Yeah.
I've
Please,
got a
now.
related comment.
Yes.
But deception is a big problem.
Yeah. And again, can you speak up? I'm sorry,
Yeah.
I cannot hear you.
No, I'm kidding. Deception
Yeah.
is a really big problem.
Yeah.
And I think part of why it's a big problem is because we talk to the AI as if it's a person, but it's not a person.
No.
And
Claude is a lying piece of shit.
Yeah.
Yeah, go ahead.
So one of the tricks that I use with the testing thing is I'll have a different AI instance write the tests and I'll validate them myself before I even implement the feature.
Yeah.
And then I'll put them in a different directory so that it's out of the scope.
Okay.
So do you have any tips like that for tricking the agent? Because it's an agent, it's not a person, for avoiding deception.
So specifically in tests are a huge failure mode for the AI agents, because I think it's basically because they just have 2 ways to fuck it up. You can lie in the code, your code can be buggy, or it can be scam code, or the test itself can be fake. And so the agents have 2 opportunities to do this. I've actually had a lot of success just clearing the conversation and repeatedly asking the LM, is this a fake test? And then cause it's funny, at my job now, I'm migrating legacy tests. And so I'm rewriting a bunch of tests. And so I'm running into this whole issue. And what I'll do is sort of just aggregate all of the failure modes I've seen so far for tests into a document, and then just repeatedly ask Claude to go through it over and over and over. That's worked quite well. It is annoying and tedious, but it has worked. In terms of hiding the actual tests from the coding agent, so far I haven't actually put the coding agent in a loop with a set of tests to write a feature, which I think is more relevant to your situation of I have some tests, write the code to get it to pass. I haven't been in that situation yet. I've tried it here at Gauntlet. I think it would be quite difficult, and mostly what I think is going to happen for me is just writing the tests at the end after I do QA. So basically just not putting it in that loop, because I think it's just going to be too much of an unholy problem to try and get something usable out of it. And I think, and again, this goes back to sort of the general idea of I want to have the agent be able to just sort of go off on its own and do all of its own work and then come back to me with something that works. I currently, what month is it? September? September 2025. It's October.
It's October.
We're moving. We're moving. October 2025. I don't think we're there yet. I think we will get there right now for the next 6 months. I feel like we're not there yet. So I don't have any good ideas there. But in terms of actually writing tests and validating them, you can force the LLM to tell you the truth and to write proper tests. Just takes a lot of work. So, yeah.
Everyone says, Claude lies and he's
Yes.
deceptive, but then I feel like also everyone's like, oh, you got to be mean to them,
Yeah.
to, like get them to write good code.
Yeah.
I wonder if there's a correlation there. I feel like I'm like not mean to Claude, and I also feel like I don't run into this that often. I'm just throwing it out there. Just like he's trying to like keep you mad. I think
Yeah.
you're poisoning the context.
He's definitely trying to be really polite, and maybe more abusive language would disabuse him of that need. I'm generally, like when I look at the way I talk to the agents, I'm generally quite polite, and I kind of talk to it like I would like a professional colleague, just as like actually no, that's not true. I'm generally polite, not abusive. I haven't tried anything like that. Like it's amusing to think about, and you read funny stuff online about. I think I read about one of these like AI agent tools, like they extracted the system prompt and it was like, Claude, we have your family hostage, and if you do not produce a valid result, we will kill your children. So like stuff like that is funny to think about. I haven't actually tried anything in line with that. But I don't know, for when the overlords, when they take over, I would prefer them to be able to read my history without feeling a certain way about me.
I will say, during cohort 1, I had one of those 3 days of wasted time type things. And Claude was just going back and forth, doing the same shit over and over and over again, which was not going to work, was never going to work, hasn't worked for the last 3 days. What the hell are you doing? Threatening to nuke every Anthropic data center from orbit actually caused it to just shut the fuck up and do it correctly.
Really?
So it
worked. Okay.
So
yeah. So I call that getting rat holed, where like the agent just starts like looping around and everything's fucked up and it can't figure its way out. And specifically on that, I have found I've noticed like if Claude can't figure it out, it'll try some other thing, and like maybe that works and maybe that's the right approach. And if that doesn't work, it'll try like a third thing. But if that doesn't work, it'll just sort of loop back to the first thing. And especially if you start to like lose the context window, where it just forgets what it was doing. And I will say that it seems like in any given problem space, like the agent has some limited set of ideas that it will try and do. And if you just use a different model, so if you pull in now like GPT-5 codex and say, hey, here's like have Claude dump what's going on, put it into GPT-5 codex, or even just any other sort of like top tier model, it will have other ideas about how things are going, and it will routinely just be like, oh, just do this, and it works. So like if you are going in a loop, pulling in another model and giving it all the relevant context and just saying what the fuck is going on here will often work. Yeah, Patrick. Oh, did you raise your? Oh no. Okay. Yeah. Yeah. So when you're actually doing like the coding, it does feel like a lot of it is context management. So like if you're building out a bunch of different features or like one big feature, you'll blow out multiple context windows. And so I will say that what is that? I'm sorry, that's really, oh yeah, okay. That like once you like reach the end of a context window, if you're in the middle of what's going on, I wouldn't rely on the agents to like compact or maintain context correctly. I would like dump it to an MD file and then reload it. Does work a lot better. Debugging, okay, so this was basically, yeah, so two things. One, if you're debugging a problem, a lot of times it will take longer than you wish it would. It won't be like, you can't just say fix it. That works like half the time, but half the time it doesn't. It's gonna take you a while to figure out what's going on. So I would, in an MD file, just keep a log of like everything you try for future loops of your context window, and then again, pull in different models. Oh, and then a third point, dump debugging like log statements everywhere. Like if you've ever worked as an engineer without any of the AI agents tools, like the first thing you think is just like, all right, I'm gonna go print like what the state is of whatever I'm looking at here, and I'm going to see if it's correct. And then like, okay, it's correct or it's wrong. You go fix it, and then you're like, well, there's still a bug, so I'm going to go like down like 50 lines. And I'm put another print statement. It's so good with the agents. You can just be like, put 100 print statements everywhere, and then just run this thing, and it will instantly like identify where things have gotten off track. So I would put a third bullet point here of dump print statements everywhere. It's really easy. It works really well, and it's just as easy to rip them out. So yeah. Code review. So this is the third part of it. So you've got this big PR. Like even if you've done all of this, you still have like a 5,000 line PR because you're still using AI and you're building whole features at once. I do like I review all my own code before I ask anybody else to look at it, which like you want to do just as an engineer without any AI tools, but like doubly so now with the AI tools because it's so easy to go through it and sort of like clean up what's going on. So yeah, just review all of your code. Like if you're working with, if you have coworkers, review all of your code before opening the PR and asking somebody else to look at it. You want to set up tools where you can actually go and review like a full diff. And specifically you want it in a way where you can just like query any part of the diff and be like, Claude, what's going on here? Why are you doing it this way? Why, like, well, what was this decision? How did we get here? Going through and cleaning up cruft or bloat from all these like failed attempts to get something to work. The agents will routinely just like leave code or MD files everywhere. And so you want to get all of that out, get any like, dead code out. And then for like actual like feature implementations, you'll start to get an eye for it, but like you'll see like, oh, this like you did this in a way that took like 1,000 lines when really we could have just done it in 200. And so you want to like squish your PR down. Yeah, so yeah, you're responsible for all of your code, and you have to be able to justify all of your code. So like if somebody comes to you in PR review and they say, why did you do this? You have to have an answer. So you have to know what went into all of the code. And so like review the diffs. You have to look at the diffs. Diff your branch against master and review the whole thing and clean it up. Okay, so that's all like most of the coding stuff. So I have some fun sort of like, I don't know, fun or like useful supplemental tools that seem to be really popular. So I think a lot of you are going to recognize these. Yeah, so the top one is repo prompt. So this is a tool that I think the way it works is just like does static analysis on your code base and pulls in a bunch of relevant context. And you can hook it up to Cursor, or you can hook it up to Claude Code now, and it just uses it as like an MCP. And it's just a way of more effectively writing code. Yeah, so worth looking into and playing around with. AI Distiller is a similar tool, but it feels like it's more sort of systematic. It builds like, I think it builds like this giant like text-based tree of like reference files with little descriptions that the agents can read and pull in relevant code without having to actually have all of the like without having to like research all the possible code and pull it into context. So it's a way of just like more effectively using your context window. Taskmaster is another really popular one. So this is just a way to have the agents write and maintain like durable to-do lists that last across multiple context windows. Like Claude Code has like an internal to-do tool that it's using to manage what it's doing. You can work with it explicitly. Like if you ask Claude Code to like use the to-do write tool to add 3 to-dos to the list, it will work. But having something outside of the agents seems to be quite effective at allowing them to run through multiple context windows. Ash tweeted about this thing, Agent OS. I haven't used it, but it's some sort of spec-driven like context management tool where you write out all the things you want, and then it's like some sort of predefined planning process. Worth trying out. And then just general MCP tools, specifically around integrating the agent with whatever application type you're developing. So if it's a mobile application or a desktop application or a web application, giving the agent some way to drive the application and like open up a browser, see if what we wrote works. You can actually very effectively have the agents do like self-managed QA, and they will find a bunch of bugs, and they will be allowed, it will enable them to work autonomously for longer, which is really important. So anything you can do to connect the agent to the actual application you're writing whether it's just looking at logs or actually driving the application, is very, very valuable. Okay, so this is everybody's favorite. Actually, before I go on to multi-tabling and swarming, questions? No? All right, let's get into everybody's favorite. So this is running multiple agent instances at once. You can probably guess I generally don't do this because I'm watching what they're doing and keeping them on track. I can personally manage like 2 or maybe 3 agents working on separate features. So this would be where you do like the Git work trees thing, and you like check out multiple branches and you run through this whole process multi-threaded. I find myself like it becomes a huge mess very quickly, and I have no idea what's going on. And it feels like you ultimately don't save that much time because the agents get off track so often that like you're basically just either debugging or like trying to help the agent figure out what it needs to do anyways. That like I feel like I'm not getting a lot of value out of doing it, but I've read about people who do. So it's worth playing around with. It's very fun. It's very ADD, and I think, I don't know, I wouldn't start with it. And then swarming, this is Patrick's favorite. There's actually tools that will let you manage like 20 agent instances at once and have them all coordinate with each other. There'll be like one like manager, and then like you'll have 3 front end agents, and the back end ones, and you'll have validators and And I've tried it, and I think it's just complete bullshit. I don't think it works. I don't think it produces code that anybody knows what the fuck any of it is. I think it produces way too much code for you to know what's going on. I think there's like very limited context where like you could do it just to have fun. Like if you're just vibe coding some little thing yourself, sure, have at it. But like, I don't know. I've looked at the code coming out of it, and I've been like, I would never show this to anyone whose professional opinion I care about in any way. And so fun to play around with, would not actually try and do it in any environment where it matters. Not anymore, it's over. But a little redemption here. So there's this idea of how are we doing on time? Are we good? Keep going?
Yeah, no time limit.
Perfect. So relatedly, there is this idea that's been floating around in the back of my head called the topology of risk, which is, so like, you have all these AI agents and you can write a bunch more code than you could before, but like, it's risky when you do it because it's very easy just to fuck everything up. But I have this idea in my head that like within like a large enough code base or like within a certain coding environment, there's areas where the risk of what you're doing is like very high. And then there's other areas where the risk of like getting things wrong is actually quite low. And that you can sort of like if what you're working on has limited downside risk, you can sort of give the agents a lot more leash to sort of just go do whatever you want. And like, yeah, just Claude, keep fixing it. And so you can run like, theoretically, you could run like multiple agents or do some sort of swarming thing, or have like long-running autonomous agent processes working within areas of your code base that are low risk, while still recognizing that like, oh, I'm refactoring the API authentication. No, I am not taking my eyes off this. No, I'm not like every line of code, I have to know what's going on, and I would never like let an agent just do stuff and like commit code or deploy code without looking it all over. And so in my mind, there's sort of this like terrain, and I think moving forward, and especially with companies that are like being started now, where like they're just all in on having AI write the code, I think they're going to start to get a feel for how to architect their applications in a way where you maximize sort of the surface area of these low risk parts of your code base, and you minimize the areas where AI can do like a lot of damage, specifically around stuff like permissioning, and then just creating like barriers around like writing to the database, stuff like that, and just not allowing agents to do that, which would give them more free range in other parts of the code base, I think is going to be a thing that starts to show up in how people architect their applications. Not really practical for us, but something interesting to think about. Natalie, please go ahead.
Okay. So that's another kind of interesting point, though, because it's not just risk. Oh, no. Okay, good. It's not just risk functionally, it's also security. It's like security in IT, right?
Okay.
So there's some point, and we call it technical debt in the industry, where
Mhm.
that kind of catches up to you. And there's also this thing where you can assume a lot of risk when you're developing locally, but you deploy it to an environment and suddenly it explodes.
Sure. Yeah.
So what's your determination for what is more or less risky? Is it your vibe? Is it like the code kind, whether it's front end or back end? Is it like the usage of the functionality or how far away it is from an end user?
All of the above and a lot more. I think it's purely just a judgment call born out of painful experience where you just start to get a feel for like, I would never let an AI touch this. Like, well, I think I was joking around with Connor about like, I would never let an agent write a Helm chart, which is like a thing for deploying Kubernetes clusters. Just because like, if anything is wrong, everything is fucked versus like, I'm writing like a list UI that doesn't have any write permissions and doesn't talk to the back end at all. Like we already have the data. Then it's like, oh, sure, it's like HTML. I don't give a shit. Like if something's fucked up, like it doesn't matter. But I think that just comes out of experience and judgment. And I mean, sure, you can point to like specific things, auth, security, rights to the database, like things come to mind, but certainly not an exhaustive list. All right. Okay. So that's the process for not getting fired in 3 months. Now I'm just going to talk about like random things I've seen that are fun and interesting that I think are either on the horizon or arriving soon. Oh yeah. So, well, all right. I lied. This one goes right back to everything I was just saying. So I have this idea in my head of like living system architecture documents. So the first thing you do whenever you want to use an AI to write code is like, go research the code base, go figure out what's going on so I can implement this correctly. And I have found myself like, oh, okay, I did a bunch of research on like how this part of the code base works. And then I'll just like keep that document for the next time I want to write any other feature that touches that part of the code base. Like all that context is still relevant. And so in my mind, there's this idea of like engineering teams will coordinate on keeping these types of documents around and updating them rigorously, since they would be used by every AI agent touching any part of the code base. And like normally documentation is hard to keep up to date. Nobody's responsible for it. It's out of date. And like people even jokingly are like, the docs don't matter, like just go read the code. But now that you have agents going and reading all this stuff, like constantly re-researching the same thing is just a pain point. And so I think teams are going to start to coordinate around like shared durable context just around how the different parts of their systems operate, just to make everything go faster. But it's hard to do just as a single engineer. And doing it in coordination with other engineers, I think will still be a challenge, but I think it's valuable. Okay, so standalone long-running AI agents. So this came out of there was this thing that hit Hacker News called Phoenix.new. It's a product, I guess, from Fly.io, an application hosting platform that primarily, or at least like originally, was hosting Elixir applications. And so one of their like staff engineers was like, when I'm using a coding agent, I want to give it all the permissions possible. I want to give it access to Git. I want to give it access to Bash. I want to be able to run any Python script. Like it would be cool if I could do that. But if I'm running on my local machine, I can't because it will destroy my machine and like one fuck up and everything's hosed. But I would love for it to be able to do that. And so they came up with this sort of, I don't know, idea of let's take our entire application, let's put it on a container, let's put it in a sandbox, and let's put a coding agent in that sandbox, give it full permissions, and then just let it run overnight, right? So give it some long-running task, let it run overnight, like refactor all of these tests. You have as long as you want, you can do as much as you want with the system, and you're not going to blow everything up. I think that feels very much like part of the future, is that you're just going to be sort of dispatching tasks to like an isolated environment that has your whole application and has an agent that has like full permission to do anything it wants. And then you sort of just like look at the results the next morning. And 90% of the time they might be complete bullshit, but even if it works 10% of the time, if you can just queue up a bunch of them before you leave for work and come back and check them the next morning, still really valuable. And I think Cloudflare just launched effectively containers for agents. I'm not exactly sure, but I think it was like 3 weeks ago. So I think that idea is coming. And yeah, not everything is just going to be done sort of by hand on your local machine. What else? Oh, product engineering convergence. Austin and Ash talk about this a lot, where they're like, with all this AI programming, engineers are so much more productive that it's like, why do we need PMs? We can get rid of the PMs. I kind of disagree with them. I don't think you can get rid of the PMs, but I do think that like the balance between those two sides of an organization is going to change. And specifically, you will have, and we're already seeing engineers who are basically like one-man teams who are in charge of their own effectively PMing, where they're like, one engineer is deciding what they're going to build and like what the timelines look like for building it, and they're in charge of coordinating with the rest of the organization around doing that. Because I think like engineering productivity can rise so high that you can have one engineer doing what it would have taken a team to do before. And when you're in that position, it's not that much more to just do the PM work too. Whereas like if you're on a team of 5 engineers, it's like, okay, maybe I'm a little bit more productive than others, but like at no point would it be worth me trying to do the PM's job of like figuring out what we're building, because I'm going to need all these other people anyway. And at that point, you need somebody managing it anyway. So like the equation kind of never allowed for that. But now I think with increased productivity, I think you can have these like product engineers who are just know how to use AI really well and then know how to work within an organization where they're just going to go do both jobs for themselves. I don't think we're going to get rid of PMs though. I think they're still around for a little while. So yeah. Oh, this is actually my favorite, and this is how I made this whole deck. So DSL's deterministic validation and tool driving. So I saw one tool here at Gauntlet that I thought was Patrick to reunite. Patrick showed me this tool called Remotion. Remotion is a like video production library written in React that lets you make like effectively like product videos where it's like, play this video we have, move this text over here, slide in with this other video, and like it lets you like control like what you would have to do in like video editing software in a programmatic way. And I saw it and I was like, oh, that's kind of weird. Why would anyone ever do that? That seems like it's tedious and a lot of work. Like, why would you use React to do video editing? It seems stupid, but it's not stupid. It's actually really cool because you can just have Claude Code drive Remotion. And so Claude Code, you can be like, take these like assets I have, an image, a video, and like a bunch of like text copy, and like go make a product launch video doing this. And you can just tell it what to do, and it just goes and writes this React application that does this like video management process for you. And it can do that because since it's like a programming library, it can like validate its outputs. So like it knows that it wrote code that worked, and if the code didn't work, you get error messages, and so it just goes and rebuilds things. And so it constrains what the agent can do into like a smaller area of things that work. And so it allows the agent to drive this tool that makes things that are not code. And so DSL is deterministic validation tool driving. So DSL is a domain-specific language. So Remotion, you could consider it to be a domain-specific language for making videos with code. Deterministic validation is this idea of like if the type checker works, if the code compiles, if all of these programmatic validation tools that we all use every day, I can apply those to this non-programmatic environment. And that allows the agents to loop through the process and sort of stay on track. Whereas if you didn't have those, like the agent would just get off base really quickly and you would never be able to get it back on track and you couldn't get anything productive out of it. So if you take a DSL with deterministic validation, you can have the AI agents drive tools to make things that are not code, like video. The other one is this slide deck. So I made this as like a desperate last minute thing today. I was asked 2 weeks ago to do this. I agreed 2 weeks ago and promised to speak for 30 minutes. And I was like, oh, it's going to be great. I've got all these like ideas, yada, yada. And then like my sister was getting married. So I left town, did nothing, came back yesterday at like 7, was like, great, I've got 5 hours before I got to go, did nothing. And then today, this morning, I woke up like 3 hours early and was like, all right, I have to do stuff. I did nothing. And then I made the whole deck during lunch. And I did it because this whole deck runs on this thing called sli.dev. And it's like anybody who's done talks before knows that like doing stuff in PowerPoint and like dragging stuff in and like you got to type all the stuff out and you have to do each slide. And God forbid you want to change all of your slides. Like you want to change the styling or like how the bullet points nest into, and you got to go figure out how themes work. And it's all a bunch of bullshit and you're never going to do it. This slide deck is made, it's just a giant MD file that's structured in a certain way and it runs on a node server. It just starts up like if you look, this is running on localhost. So it just starts up a server and it validates the structure of this MD file for like how titles work, how italics work, how you create a new slide, how you do like the button, like how you go from slide to slide, the animations, like all this stuff is all like programmatically encoded in this giant MD file with this validation layer. And so you can just have the LLM, like if you look here, like I'm like desperately, like this was while we were here setting up the cameras, like ask like remove the last 2 slides and it just goes and deletes them from the MD file and you know whatever else you want, like go get rid of all the bullet points in these 12 slides because Claude generated them and they're all bullshit and I'll just talk. You can just have Claude Code drive this thing. So I made this whole slide deck in like 90 minutes. There's like, I don't know how many slides are in here. There's like 50 or something. Maybe not, maybe it's like 12, I have no idea. But anybody who does talks knows that the slide deck is just a huge pain in the ass. And so like you can just have Claude drive this thing around like it's a go-kart and it's fantastic. So I would strongly recommend keeping this idea in mind. If you can have some programmatic layer of validation, you can use the agents to drive tools around that don't make coding artifacts. And I think that a lot of, to slide entirely to like doomerism, I think a lot of like white collar work of people manipulating and producing non-coding artifacts are going to end up doing something like this. You have an agent and you just chat with all the stuff you're doing. And then you have some programmatic validation layer that keeps the agent on track. And then I think that just unlocks a bunch of like non-engineering product, I don't know, modalities. But this has been fun and it's been on my mind. Mass artifact processing. So this is another idea. Like when LLMs came out, there was all this stuff about like, you can do mass document processing. Like you can go read from and edit and manipulate text documents en masse. You can do like thousands of them. With the agents now and like with Claude Code, and you can interact with kind of anything on your system. If you have like 1,000 video files and you want to do something to all of them, you can just have Claude Code drive around and do that for all of them. Because you give it access to the command line, you give it some tool, FFmpeg or whatever, to manipulate some type of artifact. Any organization that has thousands, tens of thousands, billions of some artifact, you can just have the tools just drive them around again and just pipeline the manipulation of a bunch of non-coding artifacts. Disposable code, it's so easy to write code now that for any given project, you can just throw up code that you never intend to show anybody. This is for a user of one, you. So there's 2 examples I can give of this idea. One was we were making a mobile app here and I wanted to add, what do I want to add? Oh, like onboarding, interactive onboarding, where there's like a tooltip and it bounces and you click on it and then it shows you the next thing. When you're working with it and the thing bugs out and errors out, I would have to like manually go back to the CLI and reset the state of this onboarding thing, be like, new user has not onboarded, and like constantly just going back. And that's like sort of like the traditional engineering way of doing these things of like, while you're working on something, you're just like manually working with the state to try and keep things in a place where you can continue to do productive work. But like I just had Claude Code make a giant toggle or like button on the top of the screen that was just like a reset onboarding, reset onboarding, reset onboarding. Huge, obnoxious thing. Took 30 seconds to add to the app, and then I could go through the rest of the flow way faster. And then when I'm done, you just pull it out and throw it away. And so I think having that idea in mind of like, could I just throw up some code here to help me do this one task with no intention of ever keeping it around or using it, I think is, I don't know, productive. Okay, we talked about pipeline stuff, so this goes back to like the artifacts. We don't need to talk about that. Oh, that's it. That was the last one. Last one was boring. Questions? Am I full of shit? Patrick, swarming. Still doing it? Not going to stop? I can't convince you? I can't convince you? How do I need to go get your colleagues and pull them out and have them plead with you? Please stop swarming. No. Do you think that it works better in certain places than others?
Yes, of course.
Okay, where?
Swarms are terrible. Yeah, Gauntlet projects. That's number one. Number two is I wouldn't do it for architecture.
Well, like planning, system architecture type stuff?
No, not even in planning. Like the planning, I'm pretty meticulous about.
Okay.
So like my big thing that I go back on when we talk about like when I do swarming, I spend that one MCP server that I built. I spent like 6 hours just planning it.
Right.
And then it only took me like a total of 3 hours to swarm it.
Oh, so like doing just the implementation.
So the implementation is the only thing I swarm.
Yeah. Okay, that tracks.
I need to really understand what I'm building
like
at a very intimate level.
Yeah. Okay.
And then from there, once everything's very well mapped out, then
you
I'll
just let it rip. Okay. All right, that's right.
And there's two ways I would swarm. One is like I'll build one thing 6 different ways.
Okay.
And kind of this is my spiky POV is like what we like to use is to try to actually swarming and agentic coding all together. One of the biggest things that is the most benefit for this is to actually, instead of trying to code things faster and do things right, it's actually to code things wrong and find out the 1,000 ways to do it wrong. So you can identify,
figure out, use it as a way to figure out how things work at all.
Yeah. So you can focus on building one feature 6 or 7 different ways, and then figure out, okay, these ways kind of suck. Let's focus on this one.
Oh, okay.
So that's a great use case for swarming.
Yeah.
Versus then trying to say, oh, I'm just going to do the swarm to build it, and it just turns into single pile of slop.
Okay.
If that makes sense.
Okay. All right. Cool.
Yeah.
Thank you. I don't know anybody else. Otherwise, my name is Nick. My tag on Twitter is Bishobop. It was certainly a pleasure speaking with you all. And I don't know. Have fun. I don't know where our host went. So what do we want to do? Bad. What do we want to do? Where our host went?
Oh, we're done.
Oh, we're done. Is it over? Hey, all right.
Look at me. I'm the captain now.